Good. Okay. So this is a continuation of the last lesson that we did, and we were talking about VLANs, and I introduced VLANs. We managed to configure a very small network in MA VLANs. And summarizing what I did last time, I think I mentioned issues to do with. I started with. Okay, we're starting with VLANs. I started with mentioning issues to do with layer 3 and layer 2 segmentation. This is making networks a bit smaller, segmenting the networks. At layer 3, we talk of subnetting. At layer 2, we talk of VLANs. So we are breaking down a network so that it becomes smaller. And when that network becomes smaller, we have improvements in performance and security. Performance and security. Basically, that is all to do with what VLANs are. By definition, VLANs are just segmenting the network at layer 2 so that we can improve the performance and possibly enhance the security of the network. VLANs, right? We introduced my ports at my VLANs, and we said we have my access ports, and we have my trunk. So basically, if we have a switch like this, if we have another switch like this, my ports are these ones. These ports, these are access ports. And all my ports are shandisco for user traffic. So if you want to send information from endpoints, information being sent from endpoints, or endpoints, this specific example being the PCs, then my ports are attached to, they are to be configured as access ports. Then we have these ports are between my switches. These ports, they are called my trunk, .1Q trunks, right? Right, anons my trunk. And by definition, they carry multiple VLANs. My access ports, by definition, they only carry one VLAN, right? So basically what happens with my VLANs, if I have my PC's angle, this can be in PC VLAN 10, this can be in VLAN 20, let's say this is VLAN 30, this is VLAN 10, VLAN 20, VLAN 30. Communication. When a PC in VLAN 10 wants to communicate in another PC in VLAN 10, basically what happens is traffic nowhere, yosvika paPC. PC1 yosvika paswitch, PC1 inonza normal frame ratinoziva rine the source and the destination MAC address. Then parinosvika this switch, let's say switch number 1. Parinosvika switch number 1, switch rinovharaisa tag rinoratidza kuti traffic iri kuuya yabva kudevice ipi. So how does the switch know? It knows because the port attached to the switch ndo rinoconfigure the VLAN. So in this example, information painosvika paswitch, switch rinovharaisa tag rayo ndorinonzi .1Q tag iroro ndo rinenge rine information yekuti traffic iri kubva muVLAN chi. So at this point, traffic yakuzivikanwa kunzi iri kubva muVLAN chi, iri kuenda kupi as well, right? Inovhaendeswa kune rimwe switch rinori parinovhura, it is able to identify kuti traffic yabva kuVLAN 10, then yoendeswa to the respective VLAN communication head. It seems a bit messy, but if you have an idea of what I'm talking about, you probably get it, right? So basically, ndoma VLANs head, right? Issues that we had last time we did this. We could only communicate within the same VLAN. So VLAN 10 to VLAN 10 communication was possible and very easy. But VLAN 10 to VLAN 20, we couldn't communicate. And we said, interVLAN routing. You need to have what we call interVLAN routing so that we can communicate between my VLANs. Right, going into VLAN routing. Let me start with opening file array, because I think I want to do more of configurations. Let me see. Let me start with opening file array, my VLANs. Rather configure last time. Let me see. Yeah. So last time we had a very simple network. Everyone on mute. Last time we had a very simple network. This one. No, isn't end up on mute, please. Right. We had a simple network like this one. All right. Then we had PC1, PC2, PC3, PC4. And I think this was in VLAN 10. This was in VLAN 20, VLAN 10, VLAN 20. All right, let me see. All right, this was our simple network. Right. And we successfully demonstrated from this PC0 in VLAN 10, we were able to ping this PC in VLAN 10, but we were unable to ping PC in VLAN 20. Main reason even InterVLAN routing configured. Right, InterVLAN routing. What is that? By definition, we have 3 ways to get InterVLAN routing. Let me see. Right. Going back a little bit, my VLANs, we said we are segmenting at layer 2. Right, to segment at layer 2, you see there is an analog between segmenting at layer 2 and segmenting at layer 3. The analog is, if I have VLAN 10, I can have at layer 3, let's say address 192.168.10. This is a network, 10.0/24. That's a network, analog. Right, if I have VLAN 20 at layer 2, it means at layer 3, I may have another network like this. So I'm segmenting. Here I'm segmenting at layer 2. Here I'm segmenting at layer 3. Now, when it comes to layer 2, our switch is not able to route. Here I've segmented, yes, I have VLAN 10 and VLAN 20. However, switch rank will not be able to route, because once I have VLAN 10 and VLAN 20, it means I have 2 different networks. Atuma networks akasiyana. And when I have 2 networks akasiyana, to send information from one network to another, I would definitely need a router. Starting point. I would definitely need a device which is able to route. Ndopanopinda InterVLAN routing. Because I have 2 different networks zandinadzo, I will need a router so that it can be able to connect 2 networks akasiyana. So with my switch at ega, you cannot communicate between my VLANs. Why? Because the moment you create my VLANs, you now have 2 networks are different. And when you have 2 networks are different, switch rako harichaziva kudifferentiate 2 networks are different. Switch hariziva izvozvo. Chinoziva izvozvo, it's a device which is able to route. And starting point, a device inonzi route. Right. So methods of InterVLAN routing, we have one, inonzi legacy. If you have done your theory very well, you know about this one. Let me see. So panetwork yedu yangatinayo, right, panetwork yedu yangatinayo like this one. Tikaisa router here, legacy routing is anoita. You have maports, unotora maports 2 panapa. Over ngoisa router here. And port 1 iri or associate ne VLAN 10, the other port or associate ne VLAN 20. So it means 2 maports ayochama configure as my access ports, oma associate ne VLAN 10, oma associate ne VLAN 20. Then 2 my interfaces are kunoko. Also my IP addresses. My IP addresses, while they can be used as my default gateways for my networks. So let's say PC1, I think we had an address 192.168.10. Let me check. .10.3.4.10.3. Here, VLAN 20, 192.168.20.3. I can no longer put .10 here. Why? Because talk about different. When we talk different networks, because at .10 here, it means we're still in the same network. So probably, but that example, we didn't put that into consideration, but I have to change because the network is different, right? So network here, VLAN 10, I can have a default gateway here, 192.168.10.1, and I can have another default gateway, 192.168.20.1. Right. Now, when communication happens, if VLAN 10, PC1 wants to communicate with VLAN 20, PC2, right? Information yangu inoya pa switch, right? Since port iri associated ne VLAN 10, it means inokwanisa forward panapa yasvika kuno. Painosvika pa router, yasvika pa default gateway. Ikasvika pa default gateway, then it is able, router rinokwanisa kuchinja from one network to another, excuse me, depending on the address yaunenge waisa. Therefore, traffic inochinjwa yoya kunoko, yodzoka pa PC2. And you're successfully communicated between my VLANs. This process is legacy. Legacy meaning, I think chirungu chinoti legacy. I think something like that. Chirungu chinoti netsei, but I'm sure legacy inotaura zvinhu zvekudara zvisashande. The reasons why this one isingashande ndeyekuti it's not scalable. Let's say you have my VLANs 20. It will mean you need to create you need a router in my interface 20. Highly unlikely you'll find that. It will be very expensive if you do, but I don't think you'll find interface router in my VLAN in my interface 20. So it's very difficult to use legacy because for every VLAN that you have, you need an interface router so that you can use that interface as the default gateway. Not scalable. Right. So this one is not used. Let's go to another one, router on a stick. All right, same network. Router on a stick. The concept now is the same. The concept remains the same. The concept in the ukaita two different VLANs, it means you need two different networks. It will mean you need two default gateways to communicate between my VLANs. So the concept, it remains the same. To my default gateway, right? With the legacy one, for every default gateway, you need a physical interface per router, physical interface. So kana my VLAN akawanda, you need my physical interfaces akawanda. That means you need router nema interface akawanda or my router akawanda, which is not sustainable in terms of cost. Things akawanda considered. Right? We have another one, router on a stick. Instead of using multiple interfaces, it can use one interface router, and you can be able to create sub interfaces. Right. So here on this one, on this port, per legacy, I think a port attached to the router, access. Here, per trunk. The reason why port per access, let me check. My port I. Per access, why? Because angasiri kutakura multiple VLANs. You see information over per VLAN 10, ndochete inosvika nepaport riri panapa. Ndosaka yanga yakaiswa paaccess paVLAN 10, but patinoenda router on a stick, port riri connected to the router rinofanira kuiswa setrunk because it will carry multiple VLANs. In this example, kana ndiri kuda transmit information from VLAN 10 to 20, inopfuura nepapo. Kana ndichida kubvisa from 20 to 10 prep up. So this port is configured as a trunk. What else must be configured? Parouter panapa tofanira kuconfigure anonzi masub interfaces. So masub interfaces edu, I'm sure theory wise you've seen something like this. Let's say interface yedu ndeiyo owner.10.20.30 etc depending VLANs aunawo ndokukreata masub interfaces. So for every sub interface it is associated with a specific VLAN, and that sub interface is configured an IP address. That IP address becomes the default gateway for that specific VLAN. I think I'm going to be configuring that, but I'm just giving a brief background so that we understand this is related. Now, when communication happens, VLAN 10 yakuda communicate ne VLAN 20. Here information per switch, trunk yotora information endesa ku router ro associate information yabva kunoku ne sub interface. You associate nekwairi kuenda sub interface roita default gateway, kwairi kuenda yotumira to another default gateway which is another sub interface. So kana iri kubva ku10 inopindira mu10 yoendeswa ku20, yapinda mu20 then it can easily go back ku PC iri muVLAN 20 or any device iri muVLAN 20. And basically communication happens like that. So that is method number 2. Ndeye create my sub interfaces. Like I said, the concept remains the same. Can also communicate between my VLANs. You're communicating between two different networks. You need my default gateways, two different gateways, because those two networks akasiyana. So the first one, multiple physical interfaces, multiple default gateways. The second one physical interface. You can be able to create multiple sub interfaces or multiple default gateways. The last one, we have layer 3. You can say layer 3 switch. All right. I'll explain why layer 3 switch example is most used. All right. The one in a layer 3, let me see. Network edenga yakadai so all right. Ndopa inga yakatangira 10, 20, 10, 20. All right. Ndika introduce a layer 3 switch. Layer 3 switch is able to route. Layer 3 switch is able to perform duties upper layer 2 as well. Right? It's able to switch. Right. So it means that as a layer 3 switch, I can easily remove this. Networks, I can easily remove this. This a layer 3 switch rank panap. Right? This information is a panap. Right. Advantage one and up to one up and instead of using my switch, then my routers in the two methods that I mentioned, here I can only use one device to perform both switching and routing. Right. Another advantage, Tarisa, panapa with the other methods, traffic will need to move from a switch to a router. Legacy, it always in a multiple interfaces. What happens can only multiple interfaces. Traffic in yakawanda, it will need to be routed back. Some multiple interfaces. In terms of performance, it's not okay. Here as well, the two devices are communicator. Can two devices are communicator? It means traffic each other from the switch, each other to the router, each other to the switch. It's much better to have a layer 3 switch because traffic here is being switched and routed internally using only one device. Can only multiple devices are communicated in terms of performance. It's much better to have only one device because traffic here is internally instead of having multiple devices. So that's a number of reasons why probably layer 3 is best to use. Now, per layer 3 concept remains the same. Here now, my ports aya unoisa VLANs ako layer 3 switch switch to begin with. Unoisa VLANs ako ese configure VLAN 10 VLAN chakadaro. My ports aya nda highlighter zvinoti access hapana trunk hapana chi ese access ports, right? Wapedza create ma virtual interfaces. Right, so create a interface VLAN 10, create interface VLAN 20. Create my SVI akho, omapa my IP addresses, or enable a link. My IP addresses are my SVI akho, they become my default gateways, which can be used by devices and devices to communicate between my VLANs. So it means kana ndado communicate from VLAN 10 to VLAN 20, information yangu ikasvika panapa inoendeswa switch visual interface rawacreata rere ndo rinenge redefault gateway. You can switch interface VLAN 10, then it can easily be routed kuenda VLAN 20, then information yako yodzoka kudai, and we have successfully routed between my VLANs. Right, now chasara apa yanyaya yemaconfigurations, which is very, very simple. Right. I think I don't have I don't have enough time to do my configurations. So I'm going to end this session so that I can restart. You log in again, create a quick more configurations. I think for the two, probably for all the three methods that I mentioned, so that you see how InterVLAN routing is being performed. Right. I'm logging out. You just use the same link to log in again.